Okay, yes. So we are back. Um, the goal for today, as I said it in the previous video, is to just recap everything we knew so far, and get to a point where we're gonna do a new exercise. And we have like 2 hours because until one, and I have a meeting at one or something. So I'm meeting with a friend. So and yes, regardless of what just happened, let's acknowledge that whatever happens really, like with my job or anything, whatever happens, the sole goal is to just go through this book because my good friend recommended to do so, and I have the help I need. So it's a personal challenge for myself to do it, and this is something regardless of what happens. Like daily we can spend 1 or 2 hours on this and see where it will go. Just really the only goal is to go through this book. It's gonna be very difficult if I'm gonna have to look for a job. I'm so terrified of that situation, to be honest. It's gonna be so shitty, but we are not at the moment, we are not at this situation, so we will have time to worry about this when we are there. Okay, for now let's focus on what we had a task, we had an idea to do, so let's do it. So we have an example code for word in words. What is happening here? Which of the tokens are reserved words and which are just variable names? Does Python understand at a fundamental level the notion of words? Beginning programmers have trouble separating what parts of the code must be the same as this example and what parts of the code are simply choices made by the programmer. The following code is equivalent to the above code. For slice in pizza, print slice. So the slice is the variable name, and the in is I don't know what. Anyway, it is easier for the beginning programmer to look at this code and know which parts are reserved words defined by Python and which parts are simply variable names chosen by the programmer. It is pretty clear that Python has no fundamental understanding. Yeah, I know. But if our program is truly about reading data and looking for words in the data, pizza and slice are very unmnemonic variable names. Choosing them as variable names distracts from the meaning of the program. After a short period of time, you will know the most common reserved words, and you will start to see the reserved words jumping out at you. The parts of the code that are defined by Python for in, print, and this thing are what is this column? Colon are in bold, and the programmer chosen variables word and words are not in bold. Many text editors are aware of Python syntax and will color reserved words differently to give you clues to keep your variables and reserved words separate. After a while, you will begin to read Python and quickly determine what is a variable and what is a reserved words. Debugging. At this point, the syntax error you are most likely to make is an illegal variable name like class and yield, which are keywords, or odd job and US dollar sign. What the fuck? Illegal variable name, which contain illegal characters. If you put a space in a variable name, Python thinks it is two operands without an operator. That name equals 5. For syntax error, the error message is don't help much. The most common messages are syntax error, invalid syntax, which is not very informative. The runtime error you are most likely to make is a use before definition that is trying to use a variable before you have assigned a value. This can happen if you spell a variable name wrong. Variable names are case sensitive, so late latex is not the same as latex. At this point, the most likely cause of a semantic error is the order of operation. For example, to evaluate one button plum, you might be tempted to write so is not the same. At this point, the most likely cause of semantic error is the order of operations. For example, to evaluate, you might be tempted to write blah blah blah, but the division happens first, so you would get P, which is not the same thing. There is no way for Python to know what you meant to write, so in this case, you don't get an error message, you just get the wrong answer. Yeah, see, and the glossary actually concatenate, assignment, comment, evaluate, to simplify an expression by performing the operations in order to yield a single value. Expression, a combination of variables of and values that represents a single result value. Floating point. A reserved word that is used by the compiler to parse a program. You cannot use keywords like if, def, and while as variable names. Mnemonic, a memory aid. We often give variable names to give us remember what is stored in the variable. Modulus operator, an operator denoted with a percent sign that works on integer and yields the remainder when number is divided by another. One of the values on which an operator operates. Special symbol that represents a simple computation like addition, multiplication, or string concatenation. Rules of precedence we know. Statement, a section of code that represents a command or action. So far the statements we have seen are assignments and print expression statement. String, a type that represents singles of characters. Type, a category of values. The types we have seen so far are integers, floating point numbers, and strings. Value, one of the most basic units of data, like a number or string that program manipulates. A name that refers to a value. So, and here we are with the exercises. We did these exercises before, and it was cool. We already know this. I will try to speed this up now because I really want to get to the new part. So conditional execution. A Boolean expression is an expression that either true or false. The following examples use the operator equal sign, which compares two operands and produces true if they are equal and false otherwise. True and false are special values that belong to the class bool. They are not strings. Okay, I'm stupid again, but it's okay. Either true, either true, the following example use the operator yeah, true or false. Either true or false. These are special values that belong to the class bool. The operator is one of the comparison operators, the others are blah 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 blah. Okay. Although these operations are probably familiar to you, the Python symbols are different from the mathematical symbols for the same operations. Not familiar to me at all. Logical operators. There are 3 logical operators, and, or, and not. The semantics, the meaning of these operators is similar to their meaning in English. For example, x is greater than 0, and x is less than 10. Is true only if x is greater than 0 and less than 10. N modulo, this is how I pronounce this, n remainder 2 equals 0, or n remainder 3 equals 0 is true if either of the conditions is true. That is, if the number is divisible by 2 or so divisible. If you can divise n with 0, no. If you can devise, yeah, I mean, logical operators, it's still like, for me, that was like where I was really stuck at 42. Finally, the not operator negates a Boolean expression, so not is true if the statement is false. Strictly speaking, the operands of the logical operators should be Boolean expressions, but Python is not very strict. Any non-zero number is interpreted as true. The flexibility can be useful in some situations, but there are some subtleties to it that might be confusing. You might want to avoid it until you know what you're doing. Conditional execution. In order to write useful programs, we almost need the ability to check conditions. I don't know, I'm losing track again. I feel like I have to return because like already I don't understand this part. Like I really don't understand what are you talking about here. N is divisible by 2. It's gonna be equals 0. So if I divide 2, okay, let's just we really have to go back to basics, because otherwise I'm just gonna be really, lost. So let's say n equals 4. If true, if either of the condition is true. Okay, so let's see. So n is equals 4, and we're gonna put the same thing. I have no idea what's going on. Why I cannot do this? Okay, whatever. So n So what I have to do, I have to print it still, right? I still have to print, otherwise it's not gonna show anything. So we're gonna print n. So it's gonna print 4. Is true if either of the conditions. What? Okay, see, this is a good idea that we are actually checking, because like we don't know what we want actually. Man. Is true. But so if I use the print function, it's only gonna I need a statement. What am I trying to do with this? Jesus, this is so strange. So if I remove the print, what will happen? It does nothing. So how can I get the outcome of true? Print. Okay, maybe if I assign this as a variable as well, result equals. Show me the champion of the light. I'll show you the heaven of darkness. Yeah, see? It's true. Okay. Yeah, cool. The logical operator is gonna be a variable. See, okay, we've proven that this is true. Yeah. Okay, but or. So I have to like, so is there a number which is divided? No, there is not. So if I put there and, It's not gonna be. Okay. And what do we have here? And if only not, is negate, so it's not. Any non-zero number is interpreted as true. Okay, I don't understand this part. Strictly speaking, the operands of the logical and true. Okay, yeah. So this is like, so we have these logical operators and or not, which are, they have these conditions to be true or false. But if you remove the operators, if you remove the logical operators, then just use the 17 and true is true, any non-zero. So for example, if I put there 0 equals 0 and true, no. Maybe I have to put it in like brackets. I don't know. I don't think so. It's still gonna be 0. Okay. So that's it's not gonna say false, it's just gonna say true. If it's 0, if it's minus 35, it's still okay, but why? So any non-zero number, so even minus is gonna be a true. Very interesting. Conditional execution. In order to write useful programs, we almost always need the ability to check conditions and change the behavior of the program accordingly. Conditional statements give us this ability. The simplest form is the if statement. If x is less than 0, print x is positive. The Boolean expression after the if statement is called the condition. We end the if statement with a colon character and the lines after the if statements are indented. If the logical condition is true, then the indented statement gets executed. If the logical condition is false, the indented statement is skipped. If statements have the same structure as function definitions for loop or for loops. The statement consists of if x is more than 0, print x is positive. The Boolean expression after the is called a condition. We end the if statement with a colon character. Yeah, we know this. If the logical condition is true, then the indented statement gets executed. If the logical condition is false, the indented statement is skipped. If statements have the same structure as function definitions or for loops, if statements have the same structure and as function definitions or Statements like this, okay, followed by an indented block. Statements like this are called compound statements because they stretch across more than one line. So if statements have the same structure as function definitions or for loops, the statement consists of a header line that ends with a colon tag followed by an indented block. Followed by an indented block. This is called there is no limit on the number of statements that can appear in the body, but there must be at least one. Occasionally, it is useful to have a body with no statements, usually as a placeholder for code you haven't written yet. In that case, you can use the pass statements to pass the Python interpreter check, which does nothing. So if x is less than 0, then just pass. If you enter an if statement in the Python interpreter, the prompt will change from 3 chevrons to 3 dots to indicate you're in the middle of a block of statement as shown below. When using the Python interpreter, you must leave a blank line at the end of a block, otherwise Python will return an error. You must leave a line at the end of the block. Which a blank line at the block of statements is not when writing and executing a script, but it may improve readability of your code. Alternative execution. A second form of the if statement is alternative execution, in which there are 2 possibilities and the condition determines which one gets executed. The syntax looks like this. Again, we can go back because I don't understand what do you mean by line. When using the Python interpreter, you must leave a blank line at the end of the block, otherwise Python will return an error. Okay. I will get some tea or something. Okay, beautiful. We are back. We are ready to continue. I have my tea. I have my awesome mug. Look at this mug. When using the Python interpreter, you must leave a blank line at the end of the block. Otherwise, Python will return an error. What does that even mean? Like, which block? Where do you mean I should leave a block? Print done. Yeah, okay. So I guess what it means that if this is, if x is smaller than 10, print small, and then print done. If not, then print done. So let's test this. Otherwise, okay, I guess I know what you mean. Okay, I think I understand. What the fuck, man? I'm so sorry. No, I didn't mean to do that. Shit. Okay. Yeah, I know what it means. So when using the interpreter, which means you're basically using the direct code, but you're not in a, because what I'm doing here, I'm already using a file, which is a script by itself, right? So there is, here it's gonna just pass. When using when blank line is not necessary when writing and executing a script. See, so it just, but it may improve the readability of your code. So it's not necessary to, you know, we can do the same thing here. It's gonna do the same results, right? So that's it. We don't actually I don't think we're gonna even use the terminal. Alternative execution. The second form of the if statement is alternative execution, in which there are two possibilities and the condition determines which one gets executed. The syntax looks like this. If x is divisible by 2, it's gonna be 0. Print if divisible, if x is divisible when divisible, oh my god. If x divisible to if the remainder when x is divided by 2 is 0. So this is how you say it. If the remainder when x is divided is 0, then we know that x is even. And the program displays a message to that effect. If the condition is false, the second set of statements is executed. If the remainder when x is divided by 2 is 0, then we all know that x is even and the program displays a message to that effect. If the condition is false, the second set of statements is executed. Since the condition must be either true or false, exactly one of the orders will be executed. The alternatives are called branches because they are branches in the flow of execution. So this is something we should note down. The alternatives are called branches. You son of a bitch. What is the shortcut for italic? Yeah, obviously. Sometimes there are more than two possibilities and we need more than two branches. One way to express a computation is like that is a changed conditional. Sometimes there are more than two possibilities and we need more than two branches. One way to express a computation like that is a chained conditional. Sometimes there are more than two possibilities and we need more than two branches. One way to express a computation like that is a change conditional. So yes, yes, yes. Sometimes there are more than two possibilities and we need more than two branches. One way to express a computation is change conditional. So the similar things in the both of these, so we need to make a note. So during the alternative execution, since the condition must be either true or false, only one of the alternatives will be executed. And during the chained, we need sometimes we need we need more, one way to express. So this is one of the ways. There are multiple ways to do this. Only one branch will be executed here as well. There is no limit on the number of elif statement. If there's an else clause, it has to be at the end, but there doesn't have to be. Show me the champions of the light. If choice is, yeah, and we already had like an example of this. But see, it's already on the try though. If elif. If there's an as clause, it has to be at the end. If elif else. Each condition is checked in order. If the first is false, the next is checked, and so on. If one of them is true, the corresponding branch executes and the statement ends. If even if more than one condition is true, only the first true branch executes. This is called change and condition. If elif else. Each condition catching exception using try and except. Okay, so here I have no idea what I did. Did I write about nested conditions? No, I didn't. So let's go. And now I can actually enable it. One conditional can also be nested within another. We could have written the 3-branch example like this. One conditional can also be nested within another. We could have written the 3-branch example like this. The outer conditional contains two branches. The first branch contains a simple statement. The second branch contains another if statement, which has two branches of its own. Those two branches are both simple statements, although they could have been conditional statements as well.